The journey of placental development is a remarkable story of cellular communication, differentiation, and growth. It all starts with a tiny ball of cells called the blastocyst. This microscopic structure holds the blueprint for a new life. The blastocyst is more than just a cluster of cells. It has two distinct parts that are crucial for placental development. First, we have the inner cell mass, which will eventually develop into the fetus. Then, surrounding the inner cell mass is the trophoblast, a layer of cells destined to become the placenta. The trophoblast plays a crucial role in the implantation process, the very first step in establishing a connection with the mother's womb. Understanding the blastocyst stage is key to appreciating the complexity of what's to come in placental development. Think of the blastocyst as a seed with the potential to blossom into a new life. The journey is just beginning. The next stages involve finding fertile ground within the mother's uterus, where this seed can take root and flourish. Implantation marks a critical moment in pregnancy. The blastocyst, after its journey through the fallopian tube, reaches the uterine lining. Here, the real magic begins as the trophoblast cells spring into action. These cells have a remarkable ability. They can invade the uterine lining, much like a seed burrows into the soil. This process is carefully orchestrated and involves complex molecular signaling between the blastocyst and the mother's uterus. During implantation, the trophoblast cells undergo a remarkable transformation. They differentiate into two main layers, the cytotrophoblast, which forms the inner layer, and the syncytiotrophoblast, which forms the outer layer. The syncytiotrophoblast is particularly fascinating. It's a multinucleated mass of cells that actively invades the uterine lining, breaking down barriers and establishing a connection with the mother's blood vessels. This invasion is not a hostile takeover, but rather a collaborative effort. The mother's body, recognizing the presence of the embryo, responds by adapting to the needs of the growing blastocyst. The uterine lining transforms into a specialized tissue called the decidua, rich in blood vessels and nutrients ready to nourish the developing placenta. Following implantation, the placenta begins to take shape. One of the key events in this process is the formation of chorionic villi finger-like projections that extend from the chorion, the outermost membrane surrounding the embryo. These villi are crucial for establishing a large surface area for nutrient and gas exchange between the mother and the developing fetus. The development of chorionic villi happens in stages. Initially, primary villi emerge as simple extensions of the cytotrophoblast. These then develop into secondary villi, containing a core of connective tissue. Finally, tertiary villi are formed, characterized by the presence of fetal blood vessels within the connective tissue core. These intricate vascular networks within the villi are what allow for the exchange of oxygen, nutrients, and waste products between the maternal and fetal circulatory systems. The development of chorionic villi is a testament to the remarkable elegance and efficiency of nature's design. This intricate network of blood vessels ensures that the developing fetus receives a constant supply of oxygen and nutrients while efficiently removing waste products. Section 4. A lifeline shared maternal-fetal circulation and the placental barrier. The placenta is often called the life support system of the fetus, and for good reason. It's here that the maternal and fetal circulatory systems meet, albeit indirectly. The maternal blood doesn't directly mix with the fetal blood. Instead, they are separated by a thin barrier known as the placental barrier. This barrier is selectively permeable, allowing essential nutrients, oxygen, and antibodies to pass from the mother to the fetus while preventing the passage of harmful substances such as most bacteria and viruses. The placental barrier is a dynamic structure, changing throughout pregnancy to meet the evolving needs of the developing fetus. The establishment of maternal-fetal circulation is a critical milestone in placental development. The placenta acts as a lifeline, ensuring the fetus receives everything it needs to grow and thrive within the womb. This intricate dance between two circulatory systems highlights the remarkable interconnectedness between a mother and her developing child. Section 5. A dynamic journey. Placental changes throughout pregnancy. Pregnancy is a dynamic journey, and the placenta undergoes significant changes throughout the 3 trimesters to accommodate the growing needs of the fetus. During the first trimester, the placenta is busy establishing itself and forming the crucial connections for nutrient and gas exchange. As the fetus grows rapidly in the second trimester, the placenta also enlarges and becomes more efficient at transporting nutrients and oxygen. In the third trimester, the placenta reaches its maximum size and continues to mature. However, this journey isn't always smooth. Complications can arise, and one such condition is preeclampsia. This serious condition is characterized by high blood pressure and protein in the urine, typically occurring after 20 weeks of pregnancy. Preeclampsia can disrupt placental function, affecting the flow of nutrients to the fetus and leading to serious health problems for both mother and baby. The placenta's ability to adapt and change throughout pregnancy is crucial for a healthy outcome. Regular prenatal care helps monitor placental development and identify any potential issues early on, ensuring the best possible care for both mother and baby.